Right, hi everybody. In this video we're looking again at reasoning and proofs. This is the fourth video in the series. And in this video we're specifically looking at these last two things on the list. Law of detachment and syllogisms. These are things we use when we're using deductive logic. In our last video we looked at truth tables and we looked at these conditional statements. If P then Q. Right, and we made this truth table. And we want to focus on this top line here. So it says statement P is true, statement Q is true. So then the compound statement, if P then Q, is also true. There's a thing called the law of detachment, which is separating this from the table and rewriting it another way, saying that if P implies Q, this if P then Q is true and P is true, then Q must be true. So if this one and this one are true, then this one must be true. Okay, might seem a bit obscure here. When I show you examples, it'll make sense. So in this example, here's a rule, here's a true statement. If you were born in Sydney, then you were born in New South Wales. Sydney is the city, that's the capital city of the state of New South Wales. So if John was born in Sydney, and that's true, so if this first part is true, then John must have been born in New South Wales as well. Okay, so if the general rule is true, or can be assumed to be true, and then the first part, your hypothesis is true, then your conclusion will also be true. Here's another more geometrical one. If two angles form a linear pair, then their non-common sides are opposite rays. What does that mean? Okay, so these two angles, angle 1 and 2, have a common side OB. So OA and OC must be opposite rays. Well, here, AOB and AOC, AOB, that's number 2, and BOC, that's number 1, are a linear pair. Therefore, OA and OC are opposite rays. So this is our if P then Q. This is P, and this is Q. So if this is true and this is true, then our conclusion. If our conditional statement and our hypothesis are true, then our conclusion must be true. And that's valid logic. However, it doesn't necessarily work the other way. If Q is true, it doesn't mean P is Q. Okay? If your conclusion is true, it doesn't mean your hypothesis was true. If a car is out of gas, then it won't start. So if P, then Q. The car is out of gas, that's P. Therefore, the car won't start, that's Q. So if this is true and this is true, then Q is true. So that's valid logic. But this one, same initial premise, same initial conditional statement, but this time, so it's if P, then Q, this time we go Q. The car won't start, therefore it's out of gas, P. No, that's not valid, because there are other reasons why the car wouldn't start. Okay, so you have to, it has to go in this order. If P then Q and P need to be true, then you can make your conclusion about the conclusion, Q. Here's another example. Here's a geometrical circle. Here's a circle, and there's this radius and there's a tangent. And the law says that the radius and the tangent are always perpendicular. So if I write that as a conditional statement, it would say if a radius and tangent meet, then the angle formed is 90 degrees. Okay, that's a conditional statement. Here are a radius and tangent that are meeting. therefore this angle must be 90 degrees. Correct, valid logic. However, if we say, okay, here's a line segment and here's a line or a line segment, doesn't matter. They are perpendicular. So we're looking at Q there, the angle formed is 90 degrees. Therefore, they must be a radius and tangent. That is invalid logic, right? So if P then Q applies to both these, but then goes P and Q. This one goes Q, P. All right, it has to go in the right order to be valid. You have to start with a hypothesis, finish with a conclusion. Oh, of course, we call that converse error. Remember, converse is if Q then P. If your original statement's if P then Q, converse is if Q then P. It does work with contrapositives, but you have to be careful here, right? So here's an example. If a person has two hands, then they can clap. That's a rule. Let's assume that rule is true. John has two hands, therefore John can clap. That is a valid conclusion using the law of detachment. Mary doesn't have two hands. I didn't specify. Maybe she has one hand, maybe no hands. Therefore she can't clap. This is also a valid conclusion. Okay, so if P is true, then Q must be true. So if not P is true, then not Q must be true. I like to say it in this way rather than saying if P is false, then Q is false. It's the same, doesn't matter, but it looks a bit nicer to express it this way. Okay, so that was the law of detachment. The other thing in deductive logic are syllogisms. These are quite popular. You'll hear them in everyday conversation, something like this. This is a classic example. All men are mortal. Socrates is a man, therefore Socrates is mortal. Here's a meme one. Liquids take the shape of the container while maintaining constant volume. This cat is taking the shape of a container while maintaining constant volume, so cats are a liquid. Here's another meme. 2 is a number, 1 is a number, therefore 1 equals 2. Okay, so you can see that these are open to a lot of issues. So let's try and make it a little bit more formal. In mathematics, we want to use two conditional statements to reach a valid conclusion. So it looks like this. If I am hungry, then I'll go to the restaurant. That's a conditional statement. Here's another one. If I go to the restaurant, then I will spend money. Therefore, I can synthesize these two saying, if I'm hungry, then I will spend money. Okay? These sort of cancel out. We do this all the time with geometric laws. If two lines on a plane are not parallel, they will intersect. If two lines intersect, they will intersect at one point. So if two lines are not parallel, they will intersect at one point. I've taken these two rules and made them into one rule using a syllogism. So the format is if P then Q and if Q then R, if both of those are true, then we can skip the Q's, jump the Q, P, then if P, then R. Okay, let me show another example in a minute. Just remind you, these are called premises. These first two are your premises, and this is your final conclusion here. We need to check, if you follow this format, you will get a logical conclusion. If you don't, you won't. Okay, so here's an example. If the wind is above 100 kilometers an hour, then the typhoon warning is raised. If the typhoon warning is raised, school will be cancelled. So if the wind is above 100 kilometers an hour, school will be cancelled. Okay? There's obviously a reason for that. This is the reason, but we don't need to discuss that. We can just logically jump from P to R, not have to deal with Q. So we call these first two statements as our premises, and then we have our conclusion. It has to fit the pattern though. So here's an example that's invalid. If Andy trains every day, he will improve his time. If he improves his time, he'll make the track team. So if he trains every day, he will win a gold medal. All right? So you went if P then Q, and then if Q then R, and then you went if P then X, right? Something that's not part of these premises cannot be part of the conclusion. Here's another invalid example. If Andy trains every day, he will improve his time. If he improves his time, he'll make the team. If he doesn't make the team, his life is over, right? This is a non sequitur error, fallacy, right? His life doesn't depend on him making the track team, okay? And none of that has nothing to do with these premises here. Okay, so there is the logical, valid logic. Okay, lastly, people can do this, take it to the extreme, all right? If Andy trains every day, he'll improve his time. If he improves his time, he'll make a track team. If he makes a track team, cousin Joe will be jealous. If Joe is jealous, he'll be sad. If he's sad, he'll eat ice cream. If he eats ice cream, he'll get sick. So if Andy trains every day, Joe will get sick. Well, yeah, that's valid logic, but it's not really sensible. It's a logical fallacy ad nauseum, just taking it to the extreme. All right, guys, that was a lot of information in a short time. So the best thing you can do now is practice. Ask your teacher for some questions. See you later.